Okay, welcome to this video. We're going to be having a look at a practice paper for the Paper 1 Non-Calculator Higher Tier exam. Now don't forget, once you've got this paper, you can scan the QR code on the front to get back to the video at any point. We are going to be firing straight into this as we have no time to waste, so we're going to get started on question 1 straight away. Now question 1 here is asking us to multiply decimals, so we need to remove the decimals from here, so we have 2 jumps out the first and 1 jump out the second, leaving us with 634 that we're going to multiply by 52. So 2 times 4 is 8, 2 times 3 is 6, and 2 times 6 is 12. Putting in our placeholder to multiply by 5, we have 5 times 4, which is 20, 5 times 3, which is 15, plus the 2 is 17, and then 5 times 6, which is 30, plus the 1 is 31. We'll then add that all together, so 8, 6, 9, 2 and 3, and we took 3 decimals out at the start, so we will put 3 decimals back in, 1, 2, 3, and there we go. That leaves us with 32.968, and there is our first answer for question 1. On to question 2, we have a plan and elevation. Now this one here is asking us to draw a side plan, or a side elevation, but has given us the front elevation and the plan. Now it's a little annoying that that arrow is in the way there, because I would like to draw the side elevation to the side of the front elevation, so I'm actually going to draw over the top of it. Now the reason I like to do that is because we can actually see then the height of this shape as it matches the height over here. You can see this one's quite a distance away, but that matches the height. We can then get the width of that by looking at the plan, and you can see on the plan, we can see here, this is sort of looking at that direction from the arrow, as we're going to be looking this way. So you can see that has a width of 3. So there we go, we have a height of 5 and a width of 3, and then we just need to connect that all up. As you can see, it's a rectangular shape, and there we go. Now, wherever there is a change of depth, we should add an additional line also, and you can see that there is a change of depth just here where this sort of edge sort of jumps in and it drops down. So at that same height, we want to have a line going across that just shows that change of depth there. And there we go, you could redraw that somewhere else on the grid. It's not really a problem that we've drawn over the top of the arrow there. But there you go, that is your side elevation. Our next question, we have some adding and dividing with fractions. So with adding fractions, the same as when you are subtracting fractions, we need improper fractions and we need common denominators. So we'll turn these into improper. 2 times 7 is 14, add the 1 is 15, so 15 over 7. And we are adding 1 times 4, add the 1, 5 over 4. Now our common denominators for those, 7 times 4 is 28, so we can write these both over 28. To get there, we are multiplying the left fraction, top and bottom, by 4, which gives us 60 over 28. And for the right one, we are multiplying by 7. That would give us 35. So 35 over 28 for our second fraction. We can now just add those together. So 60 add 35 is 95. And on the bottom, we have 28. There we go. It did just say in this question, work out. It didn't say to write it as a mixed number. It didn't say to write it in its simplest form or anything like that. So we can just leave it as 95 over 28. If you do convert it, you're not going to lose marks for that, but it's just a little bit of a waste of time if it doesn't ask for your answer to be written as a mixed number. I think 28 fits into 95 around 3 times. That would go up to 86, and then we would have a remainder. So it goes up to 84, and we would have a remainder of 11. So you could write it as 3 as 11 over 28. However, it is absolutely fine to leave it in that form, given how the question has been asked. For the next one, we have some dividing fractions. Again, we'll write that as an improper fraction. So 1 times 5 is 5. Add the 1 is 6 over 5. And we're dividing that by 3 over 4. When dividing fractions, we are going to multiply by the reciprocal. So we'll do 6 over 5 multiplied by the reciprocal of 3 over 4, which is 4 over 3, essentially just flipping it over. 6 times 4 is 24. And 5 times 3 is 15. Now this question does ask us to write it as a mixed number in its simplest form. So how many times does 15 fit into 24? Well, it fits in once. And from 15 to 24 there is a remainder of 9. Now you've got to check really carefully here, because once you've converted it to a mixed number it feels like it's finished, but it does say write it in its simplest form. It gives you a hint that it's probably going to simplify. And that's because 9 and 15 both divide by 3. So that little fraction there, along with our 1, does simplify. We get 1 and 9 becomes 3 and 15 becomes 5. So we get a final answer of 1 and 3/5. On to our next one. Christian puts tins into small boxes and into large boxes. He puts 6 tins into a small box and 20 tins into a large box. He has a total of 300 tins, and it gives us the ratio small to large is 2 to 3. Christian says that less than 30% of the boxes filled with tins are large boxes. Is Christian correct? Now, for starters, we've got a lot of information here, but the main thing that I see straight away, we have 3,000 tins, and it's in this ratio 2 to 3. It then tells us how many tins go into particular boxes, so once we've split up the amount of tins as to how many go in small and large boxes, we can figure out how many boxes there actually are. It's a little bit strange, this question, when we have tins and boxes. There's lots of language, but that's the primary bit of information there. So we need to do 3,000 divided by the total here, which is 5. So if we do some bus-stop division, 3,000 divided by 5, 5 goes into 36 times, so 600. So we have small to large, 2 to 3, and we'll times them both by 600. 2 times 600 is 1,200, and 3 times 600 is 1,800. Now it tells us that there are 6 tins in each small box, and there are 20 tins in each large box. So to split this now into boxes, we have here 1,200 divided by 6. You could do this to the side, I'm just going to do it below the ratio. And 1,800 divided by 20 to split that up into the amount of boxes. So you might want to write next to that the fact that we are now turning it into the amount of boxes, and before that it was just the amount of tins that we had. So 1,200 divided by 6, well 12 divided by 6 is 2, so that would be 200. And for our next one, 1,800 divided by 20, well that's the same as 180 divided by 2 if we chop a 0 off both of them, and that is 90. So that is how many boxes we have. We have 200 boxes with small tins in, and we have 90 boxes with the large in. So looking at the question, it says Christian says less than 30% of the boxes filled with tins are large boxes. Well, here are our large boxes. There are 90 out of the total there's 290. So, can we work out the 30%? Is 90 30% of the total 290? Let's work that out. So over here we have 290 boxes. Now 10% of that, let's just match it all up, 10% would be 29. We want 30% to make this comparison, so we want to multiply this by 3. 3 times 9 is 27, 3 times 20 is 60, so that comes out as 87. And that gives us a good indicator that we're doing the right thing, because we're very, very close to 90 there. So 30% of the boxes is 87, but we have 90. So the Christian statement, he says that less than 30% of the boxes are large boxes. Well, we have 90 large boxes, and 30% would be 87. So no, he's not correct. So we would just say here, no, he is not correct. And it's backed up by all of our working. You could say, if you wanted, 30% of the boxes is 87, and we have 90 actually that are filled in terms of those large boxes. So there we go, there is our question there. Manipulating that ratio from tins into boxes is the difficult part there, I think. But there you go, there is a difficult sort of ratio question. Now our next question is looking at sampling and bias. So here it says there are 1,200 students and Miley is helping to organise a party. She's going to order pizza and she takes a sample of 60 students. So here's the sample. Work out how much ham pizza Miley should order. Now whenever we're looking at a sample, we want to know what proportion have chosen that option. So here 20 people chose the ham pizza, and that's out of 60. So that's 20 out of 60. Now straight away when you look at that fraction, you should be thinking that that simplifies. Now the top and bottom divide by 10, they also divide by 20. So we'll simplify it in one step, and that becomes 1 over 3. Now all that means is 1/3 of the people should want ham pizza. So there are 1,200 students in total, 1/3 of them want ham pizza. So we just need to do 1,200 divided by 3 to find a third. 3 goes into 12 4 times. We've got 2 zeros there, so our answer would be 400. Now if it doesn't divide nicely, it should do, but if it doesn't, on a non-calculator especially, you can try and make the denominator become 1,200 as well. It is much trickier with these sort of slightly higher numbers, but 20 over 60, how would we get that to something over 1,200? Now that is timesing by 20, so you can times the top by 20 as well, and you get 400 people out the 1,200. So different ways that you can look at it. This question says write down any assumption you made and explain how this could affect your answer. Well, we assume that the sample represents the rest of the people. Now, if the sample does not represent the rest of the people, then our answer could be higher or lower. So we'll just say that the sample represents the rest of the students. There we go. If not, our answer, as it does specifically ask us to talk about our answer could be more or less. There we go, or higher or lower, however you want to phrase that. But the important language there is that the sample represents, in this case, the rest of the students. And there we go, there's some sampling. Now our next question is looking at pressure, force and area. It's a relatively nice question. It gives us a force of 10,000 newtons, which would be on the top of our fraction here within our formula, so 10,000. It wants us to work out the pressure, so we need to know the area. And the area is the area that's in contact with the ground. Now, it doesn't tell us the area, but it does tell us the rectangle on the base is 4 meters by 2 meters, and to work out the area of a rectangle, we just do 4 times 2. So the area is 8 meters squared if we're going to write it as an area. When we put it into our formula, we just need to put the number 8 in. So we need to do 10,000 divided by 8. We can work that out down here using bus stop division again. So 10,000 divided by 8. 8 goes into 10 once, remainder 2. Goes into 20, twice, remainder 4. 40, 5 times, and then you've got the 0 at the end. So there we go. Our units there are newtons per meter squared. That is on our dotted line, so 1,250. And there you go, using some pressure, force and area. On to question 7. There are only blue, green and red pens in a box. The ratio of blue to green is 2 to 5 and green to red is 4 to 1. There are less than 100 pens in the box. What's the greatest possible number of pens or red pens in the box? Let's underline that there, the red pens. So we're going to have a look. What is the crossover in both of these ratios? So what I mean by crossover is what's in both. Here there are green pens in the first ratio and there are green pens in the second ratio, and that is represented by the 5 and the 4. Now we want that number to be the same. If that number is the same, we can join these ratios together. Now if we join them up, we'll then have a 3-part ratio and we can try and answer the question. So here we'll look for the lowest common multiple of 4 and 5, and that's 20. So that would be timesing the top ratio by 4, which will make that 5 become 20, and the bottom ratio by 5, which will make that 4 become 20. Whenever we multiply one number, we multiply both. So the first one becomes 8 and 20, and the second one becomes 20 and 5. We can now put those numbers into a 3-part ratio, so blue, green, and red. We have 8 for blue, 20 for green, and 5 for red. It says that there are less than 100 pens in the box. Now, if this ratio was the exact amount of pens, obviously it's multiples of 20, 8, and 5, whichever order we look at it in. But if we add those together, that would be 33 pens. So we can have more than this particular multiple. Now, you can have a look and we can multiply all of these by anything, because there could be double that amount. There could be 66, and that would be timesing them all by 2. If we times them all by 3, well, that would be 99 pence in total. And that is really close to 100. We can't go more than that, but we can multiply them all by 3, and it will get us up to 99 pence. Now, if we do that to all these numbers in the ratio, timesing them by 3, 8 would become 24, 20 would become 60, and 5 would become 15. And that's the really key one we want. That's the maximum amount of red pens that we could have. So that would be 15 as our final answer, and that's just looking at the total of that ratio and sort of manipulating the total until we get to that sort of limiting number there. So it had to be less than 100. So there we go, 15 red pens. Our next question is looking at a reverse percentage, a relatively nice one because it says in a sale, normal prices are reduced by 20%, and the normal price of a coat is reduced by £15. And I've emphasised that language there because in both it says reduced by. So it's telling us they're the same thing. Work out the normal price of the coat. So in a sale, if we have 20% getting taken off the price of a coat, that leaves us with a remaining price of 80%. So you just need to identify which percentage we are being given. If it tells us it's reduced by £15, well, that's the 20%. That's that little reduction. If it had told us the sale price was £15, well, that would have been the 80%. You need to be aware which percentage we've been given. Once we know that, we can just write that down. So 20% is equal to £15, and we want to turn that into 100%. Now, to be fair, this is a nice number to have, 20%, because you can just times by 5 and get straight to 100%. However, most questions, you could have 30% there, you could have 70% there. So if we follow a method that works for any of those percentages, we would first divide by 2, which gets us 10%, and that is £7.50. And then we would times by 10, and that would give us our original 100%, and that comes out then as £75. However, of course, you could have got there in one jump, just timesing by 5. That's how you get 20% to 100%. Either method's fine. Obviously, in this one particular question, 20% to 100%, we just times by 5. But for any other percentage, we would probably break it down to 10% first. So there we go, our final answer, £75. Question 9, we have a reverse mean. So it says here 4 red bricks have a mean weight of 5. Now, before we even carry on, to find the total weight of those bricks, we just multiply those numbers together. When finding a mean, you get the total, let's call it x, divided by how many bricks there are, in this case it's 4, and it would give us the mean. But this has given us the mean and tells us it's 5. So you actually just multiply these numbers together, we times both sides by 4, and we get x is equal to 20. So all we have to do is identify the mean and how many there are, and multiply them together. So 4 times 5 is 20, that's the total weight of the red bricks. For the next one, we have 5 blue bricks with a weight of 9. That gives us a total weight of 45. And for the last one, not that we need to multiply, but we have 1 green brick times 6, which is a total weight of 6, of course. If we add those together, 65 plus 6 is 71 kilograms. So the total weight of all these bricks is 71 kilograms. It says here, Donna says, the mean weight of the 10 bricks is less than 7. Well, to work out the mean of the 10 bricks, we would get the total weight, 71, divided by how many bricks there are, which is nice because it's 10. And that means our mean is 7.1 kilograms. So that mean is actually greater than 7. And Donna said it's less than 7. So is Donna correct? We just say no, Donna is not correct. And you can say if you want, because the mean is 7.1, but I've got that backed up there and we're working just above it. I can point a little arrow to it if you want, but there you go. No, Donna is not correct. And there we go, there is some reverse mean. Now our next question is looking at a cubic graph. Now it's never the nicest when you have a quadratic or a cubic on a non-calculator paper, but here we just need to be really careful finding those numbers in the table. Now, there isn't really a major pattern when looking at a cubic graph, which is a real shame because it doesn't really matter then which side I start on. I quite like with a quadratic graph, you can start with the positives and you can kind of spot a bit of a pattern, the same as when you are drawing a linear graph. Cubic, not so much, but let's have a look. Well, I'm going to start with the positive anyway because it's quite nice to just make sure I'm securing a number before I start struggling with those negatives. So that's 6 times 1, 6x, take away x squared, x cubed, so 1 cubed. 6 times 1 is 6, 1 cubed is 1, so it's 6 minus 1, that gives me the answer 5. So there you go, the first one wasn't too bad. The next one's quite nice as well, because anything times 0 is 0, take away 0 cubed, we just end up with 0. So there's quite a nice one. I've got to be really careful with these negatives now. So I have 6 times negative 1. If I work it out straight away, that's negative 6. I then need to take away, I'm going to put the negative 1 in brackets this time, cubed. So take away negative 1 cubed. Negative 1 cubed is still negative 1. When you times it by itself, you get positive 1. Times it by itself again, you get negative 1. So it's take away negative 1. When you take away a negative, that's adding, so it's negative 6. Add 1, which is equal to negative 5. So really testing your addition and subtraction of negatives here. So there we go, that is negative 5. We do only have 1 left, so not too bad so far. Negative 2 in there, 6 times negative 2, which is negative 12. And then take away negative 2 cubed. So that's take away negative 8. Okay, 2 times 2 times 2 is 8. Cube a negative, it's still negative, so it's take away negative 8. Right, there we go, we've got the same situation again where we need to add 8. So negative 12, add 8 is equal to negative 4. And there we go, we have negative 4 as our final coordinate that goes in there. Okay, so we need to plot these coordinates, and we need to plot them very carefully. We have negative 3 on the x-axis going to 9. Let's check that. Negative 3, 9 is up there between 8 and 10, so we'll do it as accurately as we can. We then have negative 2 to negative 4. That's going quite a big jump down. Right, so negative 2 down to negative 4 here. Negative 1 to negative 5. Just there. 0, 0. That's a nice one at least. 1, 5. There we go. 2, 4. That's just here. And our last one, 3 and negative 9. 3 all the way down to negative 9, all the way down there. So there we go. Hopefully you already know that cubic graphs have either this shape when they have a positive x cubed, or this sort of shape when they have a negative x cubed. So we have an x cubed here and a negative x cubed looking like this. So it does have our negative x cubed shape. We need to draw this in very carefully. You are going to freehand this one, not using a ruler. So I'm going to kind of go down. I'm going to make sure I go through each coordinate. I need to loop back up. I'm just going point to point and then stopping, so it's not one continuous drawing movement, which is always quite tricky to do. And there we go. I just need that last one nice and neat. And there we go. So there we go. There is my cubic graph, really emphasising going through each coordinate and not using a ruler. And there you go. There's your cubic graph. Just being really careful with those calculations. Much easier when you have a calculator for these ones. So there we go. On to our next one. Right, we have a company has to make a large number of boxes. The company has 6 machines. All the machines work at the same rate. When all the machines are working, they can make all the boxes in 9 days. The table gives the number of machines working each day, work out the total number of days taken. So this is about inverse proportion when we're looking at it in context and we're thinking about the total amount of machine hours. You might have seen questions like this where it says sort of 6 taps are running and they take a certain amount of hours, how long will 3 taps take and stuff like that. So here, a company has 6 machines and they can, if 6 machines are all on, it takes 9 days. So what we work out from that is 6 times 9. Now that tells us the amount of time it would take one machine. It takes 9 times longer, or 6 times longer depending on how you look at it. If we have 6 machines and we reduce it down to 1, it's going to take 6 times longer. So rather than being 9 days, it's 6 times 9, which is going to take for one machine 54 days. So if it takes 54 days in total for one machine, well, let's have a look at how many days or machine days we have going on in this scenario. Now it says on day 1 we have 3 machines, and if we think about these as days, well, day 1 we've got 3 days of work being done. Okay, it's 3 machines, but they're all working on day 1, so that's 3 days worth of work. We have 4 days worth of work on day 2 and 5 days worth of work on day 3, based on the number of machines. Now in total, if we add those together, that's 12 days of work. Let's put it up here, it's 54 days, and we have 12 days of work going on in the first 3. It says all of the days there are 6 machines on, but we don't know how many days there are, so we can't really count them up just yet. But we can say the total, we know it takes 54, take away the 12, that leaves us with 42 days of work left to do after day 3. So after day 3, there are going to be 6 machines on, so we could count up in 6s and to see until we hit 42, but actually if there are 6 left, we can just divide by 6, and that's going to tell us that that's going to take 7 more days. So it takes 7 more days to actually complete this job here with 6 machines on after day 3. So it says work out the total number of days taken to make all these boxes. Well, we had day 1, day 2, day 3, plus then these 7 days. So 7 plus 3 gives us in total 10 days. So there we go, there's our final answer, 10 days. Now that process there is always a little strange when you are sort of working out that total, particularly that 54, the fact that it'll take 54 days for one machine. And then it's also a little strange when you look at day 1 and we refer to that as 3 days worth of work, because you look at it and you think, well, no, that's 1 day of work, but there were 3 machines on. So each machine completed 1 day, just all on the same day. So 3 days worth of work, 4 days worth of work, and 5 days worth of work in those first 3, 12 in total. What was left? 42 days left, and 6 machines were going to be on. So there we go. Maybe another one to have another look at, but a good inverse proportion question. Okay, so Angel recorded the heights in centimetres of some girls. She used her results to work out the information in this table. We've got our table there. It says Angel drew this box plot, and the box plot is not fully correct. And then it wants us to write down 2 things that we should do to make this fully correct. So looking at this one then, we have 142 as our least height, so let's check that out. There's 142. I'm just going to label that on, tick it off, that's fine. The lower quartile, 154, that's 155 there. So that is 154 just before it, not a problem, we'll tick that one off. The interquartile range is 17. Now the interquartile range is the distance from the lower quartile to the upper quartile. It says there that is 17. Well, let's see, this number over here is 172. So 172 take away 154, is that 17? Let's check it out. So let's borrow, 12 take away 4 is 8, 6 take away 5 is 1, and then 0. So actually no, the interquartile range is 18. Right, so let's keep going. So actually what does that mean? The upper quartile should have been on 171. So that there should be 171 for the upper quartile. Right, there we go. That was one of our first issues. The median, it says, is on 162. Let's have a look. Each square goes up in ones, so it should be easy to read. Wow, that one there is on 161. There we go. We could have a look at the range as well. Let's have a look. The range goes from 142 up to 182. That's actually fine. So the issue here was that the median was plotted on 161 and the interquartile range, or the upper quartile, should have been on 171. So let's actually just write that in. So the median was plotted on 161. We don't need to say much more than that. It's asked us what the mistake was. There's the mistake. And the second one, let's have a look. We had 18 for the interquartile range. It was supposed to be 17, so the upper quartile was plotted on the wrong number as well. The upper quartile should have been 171. So we can write that in. The upper quartile should have been 171. So So there we go. There were our couple of mistakes there. The median was plotted incorrectly, and the interquartile range was either not read correctly or just the fact it was plotted on the wrong number, however you want to describe that. So there we go. There is our box plot. Next question, we have some simultaneous equations. Now, I know some people like to make the coefficients of x the same. I like to make the coefficients of y the same. It doesn't matter which way you do it, but I will make the coefficients of y the same here. So let's have a look. To make the number in front of y the same, we want them both to be the lowest common multiple, which is 20. So we'll times the top by 5, the bottom by 4. When we do that, the top equation will be 10x minus 20y, and that's going to be equal to 95. 5 times 10 and 5 times 9, add them together. 4 times 3x is 12x, and 4 times 5y is 20y. And 1 times 4, nice and easy, is 4. Now you might follow this rule or not. I'll have a look now and think if the signs are the same, we subtract them. In this case, they're not. So we add these two equations together. That gives us 22x is equal to, the y's cancel each other out, is equal to 99. That would have been very nice if it was 88 or something like that, but the 22 doesn't perfectly go into 99, but not a problem. We will write it as a fraction. We'll divide by 22. There we go, and we get 99 divided by 22, and that is a fraction we can simplify. So let's simplify, because we don't want to substitute that in. We can divide the top and bottom now by 11, and that will give us 9 over 2. All of a sudden that's come out as a relatively nice one. 9 divided by 2, half of 9 is 4.5. So there we go, 4.5 is our value of x. So we are having to deal with some decimals here, which isn't the nicest without a calculator, but we'll stick with it. Now, when we are substituting this back into one of these equations, because we need to put it into either the first or second equation, I would tend to always go for the one that has the plus in. However, it's 2x in the first one, and if I do 4.5 times 2, that turns into 9, which gives me a nice whole number at least. So it doesn't really matter. I'm going to sub it into the one with the plus, because I think in most scenarios I would always pick the one with the plus. However, I'm going to have to do 3 times 4.5, which isn't the nicest. 4.5 add 4.5, I'll just write it down over here, is 9. Add another 4.5 is 13.5. So there we go, it's actually not too bad. 13.5 plus 5y is equal to 1. I might even make a U-turn and decide to go into the other one here, but we'll see. We've got to take away now 13.5 from both sides. I'm kind of regretting going into this one now. So 5y is equal to 1 take away 13.5 is minus 12.5, and I've got to divide by 5. So minus 12.5 divided by 5. Not particularly nice at all. I've got to think of a way to make this a bit easier for myself. What could I do? I could maybe times the top and bottom by 2. I've got to simplify it though. It doesn't divide very nicely at all. Let's see if I can simplify it. Okay, you might just get into this situation in an exam where you do get, so you've gone into the worst one. So times them both by 2, that would give me minus 25 over 10. That's not too bad now, actually. I can divide by 10. That's why I wanted to times by 2, so I have 10 on the bottom. So there we go, that is minus 2.5. There we go, so not too bad, actually. Might have been easier to go into the first equation, but you might not always necessarily pick the best one, and you want to be able to have a strategy to figure it out so you don't have to backtrack on yourself. So there we go, if you do get a decimal on top of a fraction like that, just think how can you turn it into a nice whole number. So there we go, minus 2.5, so we had x is 4.5, y is minus 2.5, yep, minus 2.5, so x is 4.5, and y is minus 2.5, and there we go, there's some solving some simultaneous equations. Let's look at our next question. Okay, so we have some cones and spheres, and we've got the formula for the volume of both. It says the height of the cone is 10, we can see that on the diagram. The diameter is 6. The hemisphere has a diameter of 6 as well, which we can see. The total volume of the shape is k pi centimetre cubed, where k is an integer. Work out the value of k. So we just need to work out the volume of the shape, leaving pi with that. And we should have a number in front of pi, and it wants to know what that number is. So not too bad, we've got the formulas up here. So if we go for the cone, Just remember to use the radius here. This is the diameter, so we want the radius. So the radius is 3. So if we go for the cone to start with, let's put the radius of 3 into our cone formula. So 1/3 times pi times 3 squared times the height of 10. So that is 9 times 10 over here. So that's 1/3 times pi times 90. 1/3 times 90 is 1/3 of 90. 90 is quite nice to divide by 3 to find 1/3 of. So that becomes 30 pi. So there we go. The cone is 30 pi. We'll have a look at the sphere as well. It is a hemisphere, so we will want to halve this formula or just work it out and then I'll divide our answer by 2. But let's have a look. So we have 4/3 times by pi times by the radius cubed, so 3 cubed. So that is 4/3 times pi. 3 cubed is 3 times 3 is 9, times 3 again is 27, so times 27. And now I have 4/3 I need to times by 27. That's just 4/3 of 27. So if I work out 4/3 of 27, just to the side, 1/3 is dividing by 3, which is 9. 4/3 is then timesing that by 4, so times by 4, and that is 36. There we go, so that comes out as 36 pi. Now we do have a hemisphere, so not forgetting at this point that we do want to divide this by 2, as it is half of a sphere, a hemisphere, and that comes out then as 18 pi. So the volume of the cone is 30 pi, which we have up there. The volume of the hemisphere is 18 pi. So if we add those together, 30 pi plus 18 pi, and that comes out as 48 pi. So that's the volume of the shape. So the value of k, which is the number in front of pi, is just 48. So our final answer would be 48, and that is our value of k. And there we go, just substituting that radius into both those formulas, leaving it in terms of pi, and adding it all up. And there we go, bit of volume. So the diagram shows a sector of a circle of radius 18. The length of the arc is 4 pi. So the length of the arc is this bit, just here, and that is 4 pi. There we go, work out the value of x. Now the formula for the length of an arc, we use our circumference formula, so it's pi times diameter or times 2 radius, whichever one you prefer, and then we were going to multiply that by the angle over 360. Now we don't know the angle, but we know the answer. The answer comes out as 4 pi. So let's put the pieces in and see what we've got. So we have pi times the diameter. Now the diameter is obviously double the radius, so that is 36, 2 of those 18s, multiplied by x over 360 is equal to 4 pi. Now I think I prefer to write this as 36 pi over here, so I'm going to get rid of that rather than writing it all out again. 36 pi times x over 360. Now we need to actually sort of rearrange this to actually figure out what's going on. So what we can do is we can divide both sides by 36 pi. Remember, I want to isolate x here. I want to know what x is. That's the whole point. And we've got an equation. So divide both sides by 36 pi, and we get x over 360 is equal to 4 pi over 36 pi. We're kind of in a position here where we could think about simplifying that fraction now, because 4 pi over 36 pi, there's a lot that we can actually cancel off. In fact, we can divide the top and bottom of this right fraction by 4 pi. And if we divide the top and bottom by 4 pi, we get x over 360. But bearing in mind, that's just like we would do with a normal fraction, which is looking for a common factor top and bottom. You could divide top and bottom by 4 if you want and cross the pi's off. Completely up to you. It's actually probably easier just to cross the pi's off. They just cancel out. And then it's just 4 over 36, which we're simplifying. So the top divided by 4 is 1. The bottom divided by 4 is 9. So x over 360 is equal to 1 over 9. We're almost there. We just need to multiply by 360. Multiplying by 360 gives us x is equal to 1/9 times 360, which is 1/9 of 360. So I can to the side now, just do 360 divided by 9. 9 goes into 36 4 times with our 0. So x is equal to 40. And there we go, the angle must be 40 degrees. You do need to obviously know the formula for that. If you didn't know that it was pi times diameter times the fraction that we're looking at, and to set that up as an equation, it'd be very, very difficult to answer this question unless you were able to guess numbers and just continue to work them out. But of course, you would still need to know the formula for that. So that is a formula you need to know and know how to use. And there you go. And I think this step here, being really confident with the fact that when we times by 360 there, we are just working out 1/9 of 360. 1/9 times 360 is 1/9 of 360. That's quite a nice little step. Okay, we have some surds next. So we have √5 and then √8 plus √18 in the brackets. It says it can be written in the form a √10, where a is an integer. It wants us to find the value of a. So first things first, we need to expand this bracket. So √5 times √8, well, that is √40. And √5 times √18, 5 times 18, take your time to work that out. 5 times 10 is 50, 5 times 8 is 40. So that is √90. So √40 plus √90. We want to simplify those. It's giving us a massive hint there here that they're both going to have a 10 in. So that is going to be something times √10. Well, it's √4 √10 plus, and then something else √10. That must be √9. So √9 √10. And that gives us 2 √10 plus, and then 3 √10. There we go. We can add them together now. That gives you 5 √10. And there we go, there's our final answer, 5 √10. It wants us to know the value of a. Here, the value of a is the number in front of √10, so a is equal to 5. And there you go, a little bit of expanding with surds. Okay, so we have a circle theorem to have a look at. Now this circle theorem looks like it has quite a lot of different circle theorems within it. We have the bit that I'm noticing to start with. We have this angle at the centre, angle at the circumference. So I know straight away there's something I can do there. I'm just going to read what it wants. It wants us to work out the size of CDE and give a reason for each stage of your working. Okay, the reason's being really important here. We're going to have to write down our circle theorems. So CDE is this angle here. And I'm also thinking straight away, actually, look, this is one big triangle on the outside here. So if I can find this angle, then I'll be able to find this angle. Let's put an X in there. That's the one we're looking for. So let's see if I can find that other angle within the triangle. So looking at our circle theorem here, we have angle at the centre being double the angle at the circumference. So to find this angle here, we would do 132 divided by 2, which is 66, and take your time to work these out. You can do bus stop division at any point, and that is 66 degrees. So I'd want to write next to that, or you could write it down in terms of actual angle proof. You could say angle BAD equals 66 degrees, and then put your reason with it, because angles at the centre, it just takes a while to write these down, doesn't it? So because angles at the centre, there you go, are double angles at the circumference. There we go. Happy with that. It's labelled next to my working, next to the angle that I've written in. Now the next thing that we can see is there is a cyclic quadrilateral within this circle, this 4 points here, joining them all up, and opposite angles within a cyclic quadrilateral add up to 180 degrees. So if we move down to this angle here, this angle along with the 66 have to add up to 180, so 180, take away 66, that leaves us with an angle of 114 degrees. So that's 114. And the reason for that, opposite angles in a cyclic quadrilateral. There you go, in a cyclic quadrilateral. You can say sum or add up to, I'm going to say sum to 180 degrees. Again, you can label that in terms of the notation that I used in the previous part. We can just label it next to the angle if it's nice and clear and just put an arrow towards it. We can now find the angle within the triangle because we have a straight line there, and it said up here BCE was a straight line. So next to that 114, we can find this angle, 180, take away 114. Well, we already know that that's 66 as we just did it. So that's 66. And now we can find the missing angle in the triangle. So for our missing angle, our final step, let's do that in a different colour this time. So for our final angle, we first need to do 66 plus 16, which is 82. And then take that away from angles in a triangle, which obviously total 180. So 180 take away 82 is equal to 98 degrees. And there we go, our final answer is 98. You could also write here that angles in a circle, angles in a triangle, not a cyclic quadrilateral, as I was about to say, angles in a triangle equal 180. So there we go, final answer, 98 degrees, and we can write that on our dotted line, 98. Okay, on to our next question. We have some algebraic fractions. So this question here asks us to solve these algebraic fractions, but it says to give your answer in the form p plus and minus root q plus 2, where p and q are integers. Now straight away that says we're going to be using the quadratic formula, but it does mean when we have used the quadratic formula, we're not going to be necessarily having to type it into a calculator because we don't have one. But we have that plus and minus symbol, which hopefully we recognise from the quadratic formula. So we know we've got quite a tricky question on our hands here. So let's first focus on actually getting this to the point of solving it. To solve it, we want it to look like a quadratic. We want it to equal 0. So let's look at these fractions. Now we need a common denominator. So I'm going to need to multiply the left fraction by x minus 1 and the right fraction by 2x minus 1. So rather than writing this out again, I'm just going to go straight for that. Now thankfully it's only 1 on the top of the left fraction, so that's x minus 1 over. And then we have this 2x minus 1 and x minus 1. Up to you when you choose to expand that. I think I'm going to expand it now. I'm going to do it to the side. So 2x minus 1 and x minus 1. And if we expand that, that gives us 2x squared minus 2x minus 1x plus 1. So that's 2x squared minus 3x plus 1. So there's my denominator, 2x squared minus 3x plus 1. We're adding to that a second fraction, which we are multiplying by 2x minus 1. So that's going to be, I'm going to write this to the side, 3 lots of 2x minus 1, which is 6x minus 3. And that's all over 2x squared minus 3x plus 1. And that's all equal to 1. There we go. So I need to add these two fractions together. When we add them together, we've got 6x and 1x, that's 7x. Negative 1 add negative 3 is negative 4. So there it is as a single fraction now, over 2x squared minus 3x plus 1, and that's equal to 1. We need to move that denominator to the right-hand side. So we need to get rid of that so it's in a straight line. So we have 7x minus 4 is equal to 2x squared minus 3x plus 1. And now from here, we want to make that equal 0. And once it equals 0, we can put the pieces into the quadratic formula. And hopefully it simplifies relatively nicely down to the point of what we're looking for. So let's see, let's move everything to the right-hand side. So we'll minus 7x and add 4. So it's 0 equals minus 7x over here and add 4. So we get 2x squared minus 10x plus 5. We now have a quadratic that's equal to 0. And now we need to put it into the quadratic formula and try and make it match what we've got up there. So the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a. In this particular quadratic, we have a is equal to 2, b is equal to negative 10, and c is equal to 5. And if we substitute that in, negative b, negative 10 will be positive 10, plus and minus the square root of, I'm going to try and skip as many steps as I can because it's quite a long question. Negative 10 squared will be positive 100, minus 4 times a times c. A is 2, so 4 times 2 is 8, times 5 is 40, so it's 100 minus 40, all over 2a, a is 2, so 2 times 2 is 4 on the bottom. So let's simplify that. We've got 10 plus and minus the square root of 60, all over 4. Is that in the form that it wanted? Let's have a look. Give your answer in the form p plus and minus root q over 2. Right, it needs to be over 2. That's a pain, because that means we've still got more to do. I thought it would look like it was in the right form. So we need 2 on the bottom, which means we need to be able to divide the top and the bottom by 2. And at the moment, the top we can't divide by 2 because it's root 60. However, we can simplify that. So let's have a look. Simplifying root 60. Do it to the side. So root 60. That is root 4 times root 15, so that's 2 root 15, there's that 2 we were looking for, so 10 plus and minus 2 root 15 over 4, we can now divide the top and bottom by 2, and we get 5 plus and minus 1 root 15 all over 2. And there we go, we finally got there. Even that last step, there's quite a lot of simplifying to do there, even once we put it into the quadratic formula. Just double check it matches, so p plus and minus root q over 2, and we have 5 plus and minus root 15 over 2. Perfect, so there's our final answer. Happy to write that on my finish line there, over 2. Certainly not an easy question. We had some adding algebraic fractions where we had double brackets on the denominator that we had to expand. It was equal to 1. We had to multiply that over, make it equal 0, put it into the quadratic formula on a non-calculator exam, and then simplifying it all down to that final answer. So there we go. A pretty tricky question. Let's have a look at our next one. So ABCD is a rhombus. M and N are points on BD such that DN is equal to MB. Prove that triangle DNC, let's just find that first, DNC is congruent to triangle BMC, which is this one here. So we need to prove that they're congruent. So we're looking at our triangle congruency proof. We need to find some angles and sides that are the same. So can we find any to start with that are relatively obvious, sort of thinking about those triangles? Well, in the question, it tells us that DN is equal to MB. So that's 1 point. We've got DN, which is this side here, is equal to MB. There we go. And we can just say as our reason for that, given in the question. Okay. Now I like to just write next to that whether it's a side or an angle. So I'm just going to put side there. It's going to help me just to sort of link back to my final conclusion where I say which proof I'm using. Now let's look for another one. DC and CB, if I highlight that with different colours, let's just do it in different colours, there we go. They are sides of a rhombus. It says it's a rhombus. And a rhombus, all of those outside sides are the same length. So that's another side as well. So I can say DC equals CB. And the reason for that, I guess we would say sides of a rhombus are equal. There we go. And that is a side. Now, ideally, we could finish this proof off if the angle between them is also equal. So the angle between those sides, here is this one, and here is this one. So is there any way that we can say that's equal? Well, that diagonal line is splitting the rhombus in half. I don't know how we'd explain that. It's quite a strange explanation, that one. There's not really any mathematical sort of things to say when we split something in half. It's in half. But we also have, and it's a little bit of a strange one actually, this one, but this triangle here, if D to C and C to B are equal, that's an isosceles triangle. And even though it's flipped on its side, don't forget any isosceles triangle, underneath those sides that are the same length, the angles are equal. So we could use that one. So we can say angle, let's have a look, we'll say angle CDN. Let's make sure that doesn't look like an M. There you go. CDN is equal to angle, which one is it? CBM. There we go. And the reason is base angles in an isosceles are equal. So base angles in an isosceles are equal. And that was our angle. So there we go. We had two sides with the angle in between it being the same. So we would say as our conclusion, therefore, you can write all this language as if you want, angle triangle DNC is congruent to triangle BMC because we have the SAS rule. So SAS, therefore SAS, so triangle DNC is congruent. I do find with this topic you just tend to be writing down the question a lot of the time, is congruent to triangle BMC. There you go. If you think, I mean, one of those reasons we gave was literally written in the question. The conclusion that we're giving is literally what the question was asking us to do. There was only really two things that we had to actually find there. But it seems like a lot of work considering we only had to find two things. But there we go. That is geometric proof. So there you go. A relatively nice one there. I think it's quite nice to see those. But there we go. It was our SAS rule. Okay, we have some algebra and probability. So we've got some probability equations. You never know how hard these are going to be, so let's have a look. There are only n red balls and n+1 blue balls in a bag. Ellie takes at random 2 balls from the bag. Show that the probability that both balls are the same colour is n over 2n+1. That's a little bit annoying. Both balls are the same colour. That means we can have red, red and blue, blue. So it's a little bit longer than it first looked. But let's draw a probability tree and visualise what this looks like. So we have red and blue. Red, it says, was n over the total. Now if there's n red and n+1 blue, that means we have a total of 2n+1. The n and the n gives us 2n and the +1. So n over 2n+1. And for blue, it would be n+1 over again 2n+1. Now we're only really concerned about two more roots. We want the red root up here and we want the blue root down here. You can draw the whole tree if you want, but we only need those roots. Now in the case of taking a second red, the numerator would be reduced by 1, so n-1, and so would the denominator. So 2n+1 would just be 2n. For blue, again, the numerator is going to decrease, so n, and the denominator is going to go down by 1, so 2n. When you're going across a probability tree and you want those two things, you need to multiply the two things it passes through. So we're going to multiply those two and we're going to multiply those two. Now if we do that, we can write it out. So let's write it out with the numerator first. N over 2n+1 multiplied by n-1 over 2n. You can write that out with single brackets if you want. I just sort of like to do this. I mean, if you're getting this far with, algebraic probability trees, I think you can expand a single bracket without writing it all out, but feel free to write it out if you want. N times n is n squared, n times 1 is n, and then on the bottom, 2n times 2n is 4n squared, and 1 times the 2n is 2n. This is normally that moment where I say that and then I do something wrong, so hopefully we don't make any mistakes here. For the next one, we have n+1 over 2n+1 times by n over 2n. N times n is n squared, n times 1 is n, and on the denominator there, again we got 4n squared plus 2n. So there's our two fractions. For the overall probability of those two, we want to add them together, so I'm going to write them next to each other. So n squared minus n over 4n squared plus 2n plus the probability of 2 blues, which is n squared plus n over 4n squared plus 2n. It's quite nice actually, the numerators, look, n squared add n squared is 2n squared, and the minus n plus the n cancels out, so just 2n squared. And then we have 4n squared plus 2n. I mean, that's the expression there for getting the same colours. But this question wants it in the form n over 2n plus 1. So we need to factorise either the top or the bottom. We could actually factorise both. We want just n on the top. So if we want just n on the top, we want to take 2n out of the top. So you could write that as 2n brackets n. And on the bottom, we want to take 2n out as well, so that cancels off, and see what we have left on the bottom. So 2n times 2n makes 4n squared, and 2n times 1 makes 2n. We can now just cancel the 2n's top and bottom, and that leaves us with, and hopefully this matches, I've forgotten what it said, so let's have a look, n over 2n plus 1, which is exactly what they wanted, so that's good, n over 2n plus 1. It just says to show that, and we have shown that. We don't necessarily need a dotted line for that, we just show all of our proof and make sure that final piece that we write, I think that's nice and clear, is what they've asked for. And there we go, on to our next one. Okay, so some non-calculator trigonometry and a non-right angled triangle. So in non-right angled triangles, we're either using the sine rule or the cosine rule. We've got surds involved. So they're going to be a tricky question. It says find the size of angle ABC. Angle ABC is up here, opposite the 5√7. So if we want to find that angle, we can use the cosine rule. So the cosine rule is a squared is equal to, let's not write it down incorrectly, equal to b squared plus c squared minus 2bc cos a. Now we want to rearrange that because we are looking for that angle, so we want cos a on its own. Now to get cos a on its own, we've got to add 2bc cos a to the other side and take away a. So you end up with 2bc cos a is equal to b squared plus c squared minus a squared, and then you can divide by 2bc and you get cos a is equal to b squared plus c squared minus a squared all over 2bc. So that's our formula that we're using, and within that we have surds and we are looking for an angle, so we need to know some exact trig values, potentially a trig graph. Alright, we're going to have to see where we get with this. So let's label it up. We've got A as the side opposite the angle, which I'll label big A, and then we've got B and C, which can be in either order. So if we plug those into our formula, we have cos A, it's equal to 5 squared plus 10 squared, not C squared, so 10 squared minus 5√7 squared, and that's all over 2 times 5 times 10 times B and C. We need to fix all of that then, so let's see what that looks like. So cos A equals 25 plus 100. I'm going to deal with that 5√7 squared in just a minute. 2 times 5 is 10, times 10 is 100 on the bottom. And now I need to work out this 5√7 times 5√7 to the side. 5 times 5 is 25, so that's 25 times 7. I'm going to take my time working that out. 4 times 7 is 100, plus an extra 3 of them, so that's 175. So that is minus 175. That's not very nice at all. Right, let's simplify that down, see what we get again. So cos A equals 125 minus 175 is minus 50 over 100. And we can simplify that. They both divide by 50, so that's minus 1 over 2, minus a half. That would have been much nicer if it was a positive a half, because that would be cos 60. There's a few nice ones to know. You've got cos 60, which is equal to a half. And you've also, I mean, not that it really matters what sine 30 is, because we're looking at cos anyway, but cos 60 is a half. That's quite a nice one, but this is minus a half. Right, well, there's two ways that we can look at this now, because we want to know the inverse of that. We want to know cos minus 1 for the angle of minus a half, and unfortunately that's not 60. But we want to know what cos minus a half is without a calculator. Now, two ways that we can look at it. Either we can draw a little sketch of the cosine graph, which you do need to know what it looks like. It starts up at 1, it comes down through 90, dips down, keeps going. Okay, so we could draw this. It goes from 1 down to -1, and this is 90 just here. It's the only bit we need to worry about. Now, thinking about how we know that, what that value is, well, we know this value up here. That's one that you're expected to know. Cos 60 is equal to a half, and a half is just here. And if we go across to the graph, obviously just drawing a little sketch here and down, that is 60. Now, minus a half is the same distance away from 90, but on the other side. So 60 and 90 are 30 apart from one another. So if we go 30 above 90, that would equal 120. They are supplementary angles, these two. When you've got the positive and negative version, the two numbers add up to 180. But drawing a little sketch of the graph is a nice way of getting the answer there. So that final answer, it would be just the final mark in this question, is 120 degrees, and that's a really tricky one. But there we go. Using the cosine rule, we had surds involved, a nasty fraction to simplify down to, and then this use of the graph here to think about exactly where that value would fall. So there we go, 120 degrees, final answer. I think that's probably the hardest one on here just because that final step. So question 22, we've got some indices, and we need to simplify them all. So let's make these fractions improper. So 5 times 9 is 45, plus the 4 is 49. So 49 over 9 to the power of minus a half, multiplied by 4 times 3 is 12, plus the 2 is 14, so 14 over 3. We'll deal with this denominator in a second because we've just got 2 to the minus 3. We can't really do anything with that at the moment. So 49 over 9 to the power of minus a half, well, that is the reciprocal with the negative, and then the square root of both. So we need to flip them over and square root them. So 9 square rooted and on the top would be 3. 49 on the bottom, square rooted, would be 7. And we're timesing that by 14 over 3. There we go, it's not actually too bad. 3 times 14, if I just do the top for the moment, 3 times 14, what does that come out as? 14, 28, 42. And then 3 times 7 is 21. 42 over 21 is just 2. That's come out as a really nice number. So actually, if we rewrite this now with 2 on the top, we've got 2 on the top and 2 to the power of minus 3 on the bottom. Now 2 doesn't have a power with it, but it does have a power of 1 if we write that in. When we are dividing, you subtract the powers. So if we subtract negative 3 from 1, that's 1 take away negative 3. So we've got that situation again where we're adding. So that becomes 4. So 2 to the power of 4. And it does say work out the value of. So we do actually need to work that out. So we need to do 2 times 2 times 2 times 2 again. 2 times 2 is 4, times 2 again is 8, times 2 again, 16. So our final answer, 16. And there we go. And that is looking at some negative and fractional indices. Okay, we've got some graph transformations here. It says on the grid, draw the graph with this equation. So in the bracket next to x affects x, and it does the opposite of what you'd expect. So x coordinates move left and right, plus 1 you'd expect to go right, actually it goes left. So left 1, and then outside the bracket affects y, does do what you expect. So y goes up and down, minus you'd expect to go down, and that's what it does, it goes down 3. So this graph here, we need to go left 1, down 3. I need to pick some points to do that. It doesn't matter which one we pick, I'm going to go for this one first. Left 1, down 3 to check the axes, make sure it's scaled properly, which it is. So there's that one. I'll try and do these in some different colours. That goes here. The next one, left 1, down 3, goes to there. I've got loads of colours, so I'm just going to use this one. Left 1, down 3 is here. And then this one at the end, left 1, down 3, just there. And then we need to join that together nice and neatly. There we go. And obviously use a pencil and a ruler for that. Draw it in nice and neat. So there we go, that graph's gone. Left 1, down 3. There you go, relatively nice. Part B here, we've got point A is -2 and 1. It lies on this graph. When the graph of y equals f of x is transformed to the graph with equation y equals f of minus x, point A is mapped to point B. Write down the coordinates of point B. Now, in the bracket there, affects the x coordinate only, so the y coordinate here doesn't change, so y is just going to be 1 still. Now, a negative symbol like that on its own, not plus or minus something, just a negative symbol in front of the x, just changes the symbol of the x coordinate. So -2 turns into +2. So there we go, there's our coordinate 2, 1, rather than -2, 1, because the x coordinate is having its symbol switched. Next question, let's just have a quick look. Okay, this is our final question. So the centre of a circle is the point with coordinates -1, 3. Okay, so straight away we have a circle that's not centred at 0, so this will be an interesting one. The point A with coordinates 6, 8 lies on the circle. Find an equation of the tangent to the circle at A and give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. Now, it may or may not help, but I'm going to draw a small sketch of this. So -1, 3 would be a centre about here. It doesn't always help because your diagram's not going to be perfect, and sometimes it kind of just makes it look a little bit worse if it's not drawn perfect. But there we go. We'll try and sort of make it look okay. About there. Okay, there we go, as best as I can do. So, the coordinate 6, 8 lies on the circle, so it's not perfectly drawn, but let's imagine it's here. So that is the coordinate -1, 3, and this is the coordinate 6, 8. And it says find an equation of the tangent to the circle at that point, at point A. So we want to know the equation of that tangent there. So that's kind of what it looks like. Again, I've just drawn a sketch of that. You don't need to draw a perfect diagram, just a little sketch. Now, the first things first, we need to, in order to find the equation of a tangent, you need the gradient of the tangent. To get the gradient of the tangent, I'm going to need to find the gradient of this radius. The gradient of the radius is the rise over the run from -1, 3 to 6 over 8, or the change in y over change in x. So change in y over change in x. Now that goes from 3 to 8, which is a change of 5, and it goes from -1 to 6, which is a change of 7. So the gradient of the radius is 5 over 7. Now the tangent, we want the perpendicular gradient. So for the perpendicular gradient, we do the negative reciprocal. So flipping it over and changing the sign, we get -7 over 5. And we can straight away put that into our equation of a line. So y is equal to -7 over 5x plus c. Worst case scenario, we've pretty much got the majority of the equation there. We just need to know that value of c. So in order to find the value of c, we need a coordinate that's on the line. 6, 8, it says is on the line. 8 is the y coordinate, so let's put that in. Let's just label that down here, 6, 8. So y is 8. And that's equal to -7 over 5 multiplied by 6 plus c. Let's deal with that. So 8 equals, when you times a fraction by a whole number, it just times the numerator. So -7 times 6, or just 7 times 6. 21, that's 42. So -42 over 5 plus c. I need to add that to the 8. I could write it as a mixed number, or I could write 8 as a fraction over 5. It's completely up to you here, but if I write 8 over 1 and I want it to be a fraction over 5, so it's easier to add, I just need to times the top and bottom by 5. So that would be 40 over 5. So that's probably easier to write. If I get rid of the 8 here and write that as 40 over 5, I can now add 42 over 5 to both sides relatively easily. So 42 over 5, and that leaves me with, well, 40 plus 42 is 82 over 5 equals c. I can now write that equation, just putting it back into my line equation here. So that is y equals -7 over 5x plus 82 over 5. Now that right there is the equation of the tangent, but it said something else up here. It said give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. So we can't have any fractions involved, and it wants it to equal 0 basically. It wants everything on the left, so we're going to need to move everything over. First we need to get rid of the fractions. They both have a denominator of 5, which does make it much easier for us to do. We just need to times everything by 5, left and right there. So that would give us 5y equals, and then just the 5's disappear essentially, so minus 7x plus 82. Now we just need everything on the left-hand side, so we're going to add 7x to the left, minus 82, now it'll equal 0. If we put the pieces straight into the correct place, they want the x, then the y, then the number. So let's put them all in the right place. So that'll be x, 7x, plus 5y. We've had to introduce that plus symbol in front of the y there. And then minus 82, and that is equal to 0. And that is in the form they wanted. So 7x plus 5y, and then minus 82 is equal to 0. So there we go, a lot of steps there. We found the gradient of the radius. We did the negative reciprocal, put it into the equation of a line, substituted the coordinate that's on that line to find the value of c. The value of c wasn't particularly nice to find because we had to make it a fraction over 5, the 8. Adding it all together give us that value of c, and then we needed to put it in this particular format as well, which is a little bit strange. But there we go, that is the end of the paper. Obviously just making sure that we write that final answer on there. And there we go, that is our final paper 1 practice paper. And obviously, good luck on the exam. We'll have lots of papers and videos ready for those next papers, looking at paper 2 and paper 3. So there we go. I will put all the links
now,
in the description.
Hopefully you've got your revision under control and you're making great progress towards paper 1. But if you're struggling to know where to start and need to maximise your maths in minimum time, then you should sign up for my rapid revision programme, Upgrade, as you can use it to build your very own personalised revision plan. Which means all you need to do is complete my revision quiz and you'll know exactly which lessons or topics you need to work on to maximise your maths in minimum time. This is my paid programme, but you can sign up for a free trial on my website now. And if you feel like you need top tier support direction from me, then sign up for my live weekly interactive lessons, which include revision specific lessons focusing on the topics that I expect to appear in exam papers 1, 2 and 3.